Well, I want to thank Friends of San Leandro Creek, Michael, Susan Levinson, who I had the pleasure of spending an afternoon and walking the creek last week to sort of pick her brain on the latest developments, because it has been a while since I've actually been in the Lower Creek, although I've been there several times. And then I'd like to also thank Pete Alexander, East Bay Regional Park District, who provided some of the photos that are in this presentation. And I'd also like to thank Bert Mulcahy, East Bay Mud, who also provided some data that I'll be using here, and some pictures of the fish. So you want to restore steelhead to San Leandro Creek? No problem, really. Okay, I'm here. Oh, and let me back up 1 second. I'm here as Rob Leidy. Had a free Saturday. I'll be mowing my lawn this afternoon, doing things like the rest of you. I don't represent, this doesn't represent the views of the U.S. Environmental Protection Agency. Okay, so anything I say here is just my personal opinion. So yeah, I'm here to basically give you, or give people interested in restoring this creek to steelhead sort of a pep talk and a reality check on what, some of the things you want to think about if you're going to go ahead with this endeavor. Okay, next slide, please. So another way to phrase that, really, in not so cavalier a way, is to say, is it practicable to restore steelhead to Lower San Leandro Creek? Is it capable of being done when you consider cost, scientific technology, the socio-political environment, that sort of thing? And my answer to that is yes, I think it is doable, but it's going to take some work, as it was pointed out by the previous speaker. So let's walk through this. First, we're going to talk a little bit about the historical perspective on the creek, because that can inform what we can do in the future. It can give us some lessons that we can learn, some things we can try to implement by looking at that. We'll talk about current conditions. What are the current conditions? What do we need to fix? What needs to change? And those two things really will inform an alternative future, different scenarios that you might be able to implement here. Just as an aside, a quick story. When I first started sampling all the bay streams back in 1981, I sampled over 450 sites on, 75 streams. And my first introduction to San Leandro Creek was to pop in here in 1981 and see this going on. So I was down on the Lower Creek when this channelization project was first started, and I don't know exactly where that is. Someone else could probably tell me, but they were putting in a flood wall at the time. Next. I don't know. It might be nice to figure that out at some point. Okay, next slide, please. Okay, so while I give this talk, let's keep in mind the life cycle of the steelhead, okay, the creature that you're really most interested in. It's a cycle, okay, and we have to have a landscape perspective if we're going to restore any semblance of the runs, a steelhead run here. So we have ocean growth, and we need migration to spawning areas, so that's going to have to be planned for with certain types of flows. We have spawning, egg incubation, so we're going to have the right flows for fish to spawn in, for those eggs to develop without sediment over them, right temperatures, the right amount of water, oxidization. We have emergence, so again, sedimentation becomes a big deal. Once those fish try to get out of the gravels, if you have a lot of sediment on top, they could be trapped. We have the issue of juvenile freshwater rearing. Once those fish are in the creek, they need conditions so they can grow to a size to then migrate back out to the ocean as smolts. And so we have to deal with flows, and then of course back out the ocean estuary, and then it goes all the way back. It's a loop. It's a landscape issue. Next. Okay, historically, we know that we had at least 4 and maybe 6 or more species in the San Leandro Creek watershed. Am I blocking your view there? I don't know. Oh, that's 2. I guess scoot down. We know we had the rainbow trout or steelhead. We also had a run of coho salmon, possibly Chinook salmon. That's sort of iffy. Chinook salmon and coho are extinct in the watershed, or extirpated now. We have Sacramento sucker, three-spined stickleback, and prickly sculpin. They're all still here in the watershed. And then these two species, you probably had or still do have Pacific lamprey. They're just really difficult to detect. They're always found when you found where you find steelhead. And so I would be surprised if they weren't here. They just haven't been found, or that we're sampling at the wrong places at the wrong time. And then the one other species that's sort of missing that should be here is California roach. And it's possible it was here historically, but it's gone extinct because of some drought scenario after the reservoirs were built, and its habitat was just lost. So, but you do have 4 species. They're species that should be found together. Yes. Okay. Well, I think in fact, on our walk, we did see some roaches last week. So, but we do have these 4 species, and you'll find around the bay and throughout California, you will find these sort of those 4 species occurring together in many streams. So it's a natural assemblage, and that's good. And the other thing you'll note about these 4 species in yellow is, to some extent, they're all adapted to reservoirs, so they can live in reservoirs. So you have large adult suckers in the reservoirs. Prickly sculpin, rainbow trout migrate out of the reservoirs upstream to spawn. Not so much with stickleback, but certainly one of the reasons they probably do persist or have persisted is they can have a parent population in the reservoirs. Next slide, please. Okay, so here's historical view, sort of a model of what it might have looked like. We had the headwaters up in the parks in San Francisco estuary. Headwaters are a source. There was a strong connection between the source and the estuary. It was a sink in this direction. So you had water, sediment, nutrients, organisms moving downstream from the source. But it also worked the other way, where the estuary becomes a source because you have steelhead growing in the ocean and coming back up to the headwaters to spawn. Some of those fish will die, and they provide nutrients. So there's this link, this landscape connected linkage that was the historical condition. Next. Now we're going to talk about current conditions. How has that changed? Next slide. There's Chabot. So now what we have, if you sort of diagram this out, is we still have the headwaters as a source, but the new intervening sink are the reservoirs, Lake Chabot, San Leandro Reservoir, okay? Now those are a source. The font sort of is an attempt to sort of portray the strength of the relationship. They're a source of fish for the upper watershed. We have, you know, the remnants of steelhead migrating out of the reservoir into the headwaters and spawning, and then going back to the reservoir. There's this sort of strong linkage here between the headwaters and the reservoirs, but there's a break now. And so from Lake Chabot downstream, you have a very weak connection with the estuary, and you have a very weak connection coming back. There's water, nutrients, and organisms, but obviously the water is less now because of the reservoir. Nutrients and organisms have been reduced in the downward way. And coming back up, if you do have stray steelhead going up, it's still a weak connection. There's not that sort of robust connection that you saw in the historical diagram. So now it's really a tale of 2 watersheds, okay? Biologically, you have an upper and a lower. The trick is, can we link those again and produce something that's sustainable? Politically, you have an upper and a lower watershed. I'm going to be frank with you. There's a lot of interest in the upper watershed as far as understanding and studying the fish up there. East Bay Parks, East Bay Mud have spent a lot of time. They have great biologists doing studies, sampling, measuring fish, that sort of thing. In the upper watershed, probably have file drawers full of statistics on the fish and studies and numbers. But you go below the dam, and they probably have much less, maybe a couple pages. It's hard to find information below the watershed. So there's this dichotomy of interest too, and that shouldn't be that way if you think about it. Next slide. Here's a map of where the fish are found now. So above Upper San Leandro, we have various tributaries coming in that support the steelhead that now use the reservoir as their ocean and migrate into spawn. And then below Chabot, there's this little stretch where we do have rainbow trout, okay? Let's talk about those rainbow trout. Next. So here's a quote I pulled out of one of the Fish and Game surveys from 1975. From Lake Chabot to approximately 100 yards downstream from Interstate 580, numerous 2 to 3 inch juvenile steelhead trout were observed. Lake Chabot should be managed to protect and perpetuate the remnant steelhead resource. Obtaining minimum stream flows for releases Lake Chabot should be investigated. So in '75, when they Fish and Game went around and surveyed a lot of streams, they found rainbow trout / steelhead reproducing below Lake Chabot in some of those wetted areas. And they recommended that the possibility, even back then, of enhancing flows to manage those fish be investigated. Next. And in fact, if you look at some of the sampling data, there are reproducing rainbow trout recorded below Chabot Dam since the 70s and probably before, if you scoured the record, but these are years where they have been collected. So they're there, they're reproducing, they're persisting. There's a picture of one right here. So we have that resource that's hanging on below the dam. That's important. Next. Something that really is underappreciated is sort of the location geographically of creeks in relation to success of steelhead runs. At some point, steelhead in their life cycle turn to smolts. They have to get to the ocean, okay? And if you're traveling 250 to 290 miles or over 200 miles, then you're this big, you're 3 or 4 inches long or 5 inches, and you have to get to the ocean, the chances are much greater that you're going to get eaten or something's going to happen to you on that journey than if you're 22 miles from the Golden Gate, okay? So just if you think about San Leandro Creek and where it sits, the fish, it's a short reaches stream below the dam. Those fish are going to have a really good opportunity to get out into the bay, into the estuary, and then out into the ocean where they have to spend 2 or 3 years because of just distance alone. The number of threats to them will be much reduced. So that's something to think about. It's an important point to make, I think, when you talk about making the effort to recover this resource. Next. We'll talk about water. In winter, so under current conditions in the winter, you'll get high flows. Here's a stretch here that I actually back in '98 caught a steelhead coming upstream. So winter, flows could be sufficient if it's a normal year. You're going to get some high flows that, fish can move up and down with. So that's really not the major issue. The issue is late spring and summer where you have these beautiful shaded stream reach with gravel substrates and the stream's dry. That's a problem because, ideally you'll want to expand that reach of stream to allow fish more area to rear, to grow before they go to the ocean. Next. Sediment. When they built Chabot, they trapped all the sediment. Mike can probably talk to this better than I can. Caused the channel to incise. It's very steep in places because you've starved the channel of sediment. It's re-equilibrated now. There's still a lot of sediment in the system. I think there's probably enough to provide spawning areas for fish. Here's below Lake Chabot. They spawn in this reach, which is mostly large cobble, small mixed with some medium-sized gravel. So they're successful in that area. And then if you go down further, there's a lot of perfectly sized substrate for fish to spawn in. It's just missing the water right now. Next. Temperature, and this was provided by East Bay Mud, so thank you. But if you look at, do we have the right temperatures for rearing fish? And if you look at this line here, this is I got moved, but this is the 20-degree line. So ideally, fish prefer water below 20 degrees C. This is the average temperature here. This is the average minimum, and this is the average maximum. So you can see for June, July, and into August, there's a period there where the average gets above 20, but that's okay if there's enough food in the stream, because if you think about it, the stream gets warmer, the fish get hungrier faster, the metabolism's up. If there's plenty of food, they can survive. And also pools stratify. You'll get pools that will be a few degrees cooler on the bottom and at the top. And the fact that we have, healthy looking fish that are spawning and persisting below Lake Chabot shows that they're able to find those habitats, or they're getting plenty of food. They're just there in small numbers. So the temperatures look quite good in this stream, and they're very similar to some of the other streams around the bay. In fact, this could be a consequence of the Hayward Fault and groundwater percolating. And we see this in Sausal Creek. It stays extremely cold. There's trout there. They're able to persist through the dry, low flow summer months because of this cool bit of water coming in. And that's good for the future too. Next. Okay, so instead of thinking of these things as we don't, oh, how horrible it is below the dam, let's look at these as building blocks for an alternative future, okay? And I'll talk about these a little bit more. We have existing native trout populations above the reservoir and below, okay? We can use the fish above the reservoir potentially to help jumpstart the run below the reservoir. They're doing this, thinking about this on Alameda Creek with the same situation where they have steelhead that come in and out of the large reservoirs like Calaveras, San Antonio. That's a genetic resource that could be used to help jumpstart the population, if need be. Then we have fish below. We have a source of water, obviously. We have 2 giant reservoirs with water. So we have the opportunity to manage that, to properly manage life history stage flows for spawning fish, for rearing fish, for outmigration. And we also have additional existing spawning rearing habitat further down that isn't being utilized. Okay, that could increase production of the stream right here, in here for future spawning. Few significant barriers, okay? There are barriers, there's some areas where there might be velocity barriers and things down below, but there are no like big drop structures like you see around the bay and mini streams. It's a pretty straight shot up and down to Chabot and back to the bay. That's huge because those are huge capital costs if you have to start putting ladders over things and that sort of thing. So you have that going for you. And then strain. All steelhead don't always return to their native system as best we can. The reservoirs are there. They're always going to be there. There'll be operational constraints. They're always going to block complete access, but they can be used as a tool to sort of make some reconnections. And the key here, obviously, is to make these connections stronger for organisms and water nutrients. Make Lake Chabot and San Leandro Reservoir not the terminal sink anymore. It becomes a source. You have a source, a sink, but then you turn it around, it becomes a source that goes down to this sink. And so you sort of have 2 watersheds, but not really. You have what's going on below and above, but there is a better linkage. And of course, if you use fish from up here to help jumpstart this, then you sort of have reconnected, biologically speaking, the watershed. Next. Okay, so we have the existing populations. I talked about this. We can use these fish from the upper watershed if need be. You could introduce those, have them released below the reservoir to sort of augment the existing population. It's an option. Next. Okay, we have the source of water. We need to strategically use that water to create a living stream below the reservoir. Maybe a fall pulse of water, a big pulse of water when you'd expect the steelhead to come into the system to sort of grab their attention, to stimulate them to move upstream. You may not have to do this if it's a rainy year. You may get a natural pulse. You could augment that pulse. You could extend that pulse, or you could not use the pulse depending on the year. You want to elevate your spring flows so fish can spawn and rear. And you need to keep some sort of minimal flow so through the summer fish can persist, that sort of thing. So this is really what we're talking about in the flow regime, coming up with something that works for the fish below the dam. Next. As I said earlier, we have existing spawning rearing habitat that could be used. I don't know if it's underutilized. That could be studied. We can expand that habitat with more water downstream further. Next. Few barriers. This would have to be investigated. If the flows get really high, it can become a barrier by velocity to allowing adult fish to migrate up. But under certain flows, if the flow is just sitting right here at the top of this faux bank cut full flow here, fish probably can move up that into the upper watershed. At least steelhead that we caught back in '98 shows that one made it. So we probably don't know how many. There could be fish moving up every year. We don't know. But this could be modified if need be, slightly, with baffles and resting pools and things like that. You know, it's not something that's that difficult, because otherwise, you know, it's a straight shot. Next. Okay. Rob Leidy's talking, okay? So don't call EPA. If you're pissed off, come talk to me, all right? Okay. Everybody has heard of this Fish and Game Code, Section 5937, which basically says you can read this, but the owner of any dam, operator of any dam, has to release sufficient water from that dam to keep the fish in good condition below the dam. 1915 is when that law was put into the code. Okay, we're approaching 100 years. Okay, 100 years, Chabot Dam has forsaken the public trust for a century. Okay, it's the law. I don't know about you. When I go fishing, I get a fishing license. Okay, when someone builds a flood channel, they have to get a 1601 from Fish and Game. Well, they're in trouble. You don't just go out and build it. You get the permits, okay? When I go collect fish, I get a Fish and Game scientific collecting permit and, you know, endangered species permits from National Marine Fisheries or Fish and Wildlife Service. It's the law. It's just what you do. It's the right thing to do, and, you know, you should do it. The law says that there should be sufficient flows below the dam. It has for 100 years. Okay, next. So what constitutes good condition? Okay. Some of the early court cases basically said, you know, you restore to the pre-diversion or pre-damming historical condition. Now we know that's not going to happen in most cases. You got these dams, they're there, so let's be realistic. So you need to come up with a better working definition of good condition, and Peter Moyle, who is involved in, who's at UC Davis, who's Mr. Fish in California, who I had the good fortune to study under, he came up with his sort of idea of good condition in the Pewter Creek water cases, you know, and those cases, he prevailed, or those cases were settled such that flows were released that resulted in fish being, you know, considered in good condition. And so he came up with some criteria, and let's work through those. Next. Okay, so at the individual level, fish should be healthy. They shouldn't be diseased. They should be the weight that you'd expect them to be for the region. It should be reasonable. So you want flows that, you know, allow that to happen. The individual fish, if you look at them, if you net them, you pick them up, they look healthy, robust, okay? So that's one criteria. Next. Then you want to look at the population. Is there enough habitat for all the life history stages? Adults to spawn, juveniles to rear. Are they broadly distributed in the stream so they're not just all stuck below, maybe like the dam in one spot where there's water? There should be a wider distribution because that's what a healthy ecosystem would have. And then third, they should be in a community of co-evolved species. So here's a prickly sculpin, which is in the stream, which were found in San Leandro Creek. So you should be able to find the assemblage membership should be similar. The populations should be able to persist. You go through a drought year or two, they should be able to bounce back. And it should be replicated geographically. In other words, you should be able to find these assemblages in different parts of the stream, what you'd expect to find there. So those are sort of three, from individual population to community, sort of things you would apply to determine whether the flows are sufficient to maintain the fish in good condition. Okay, next. Okay. The good news is you might not need as much water as you think. Okay, especially on a short reach like this. That's, you know, what were you saying, 6 miles to the bay, from the dam to the bay? There's something that's called the physical solution doctrine. In other words, you might be able to achieve good condition with much less water than you think, okay? San Leandro Creek, if you walk it, and I was talking to Mike about this, is really one long riffle looking for a pool. I mean, you could drive a car down it. It's so smooth. And that's not good fish habitat. I think it's great for flood control, and I'm sure the flood control district would have issues with trying to create more habitat diversity, but those can be overcome. But you need the pools in the stream. And so a couple ways to do that is to reintroduce wood to the system, because wood was a natural component. When you have large wood in the system, you get pools that are created. As you can see, this log is placed across here. You can see wood. That causes heartache to flood districts, but it can be dealt with. The other thing is you can construct weirs. Not a big fan for artificially constructed features, but they can be done right. Here's Saucil Creek, okay? This is late summer before, this is like October before the rains. And what you can see happens here is you don't need a lot of flow, but you keep the pools connected. You use shallow subsurface water, and you get these pools that persist through the summer, and that's where the fish will hang out, okay? They'll be in these cool stratified pools, and so you can build these structures in, and you will have to build these structures in to be successful along other portions of San Leandro Creek, along with the water. It's not just add the water. There's some other things that have to be done. So let's keep that in mind. And then next. And then I'm going to end here with just a couple ideas. We have ecosystem-based conservation, sort of the 3 R's. So if you're at this end, preservation, there's really few opportunities. But we do have some big parks, creekside parks, public spaces, the headwaters are protected. But there's not going to be a lot of opportunities for big wholesale protection along the creek, right? Because it's an urbanized area. Restoration, there are more opportunities, and planting trees, putting in weirs, habitat improvements. There are opportunities for that, and those will have to go hand in hand with any additional flows. And then there's this whole thing, and I'm putting this in for Susan, reconciliation ecology. It's basically, there are lots of opportunities to sort of recreate the system in a novel way. Not exactly the way it was historically, but it mimics it. It's a new system, but you get a lot of the same functions. And I think you have a lot of opportunity here to really make Lower San Leandro Creek a novel system, but it will have a lot of similarities to the historical system, okay? So I think that, one more slide. And so reconciliation, management in favor of natives. This not so much here because we have a reservoir and there will always be exotics, but there are not a lot of exotics in Lower San Leandro Creek, at least the density of them. And we're shooting for the natural flow regime, mimic the natural flow regime. I love this picture, an unreconciled river. So, Lower San Leandro Creek is an unreconciled creek, and it's time to reconcile it. It's the law. I think it can be accomplished. And so that's it. Any questions? Yes. Oh, that's a good question. Yeah, it's pretty quick. So they're already set up to tolerate that. It's a physiological change. So as they move downstream and they start to enter brackish water, it starts to get saltier, and then it gets real salty, but they can transition pretty fast. Now you do have an estuary at the mouth of San Leandro Creek, and so there is an area there where there is the potential for them to transition. You've got to do it all. Now, there's different ways to do things. You can do pilot projects. For a couple of years, you can experiment with flow releases and then study the system and see how the fish are reacting. You have fish below the dam. You know pretty much where they are. You can run a pilot project where you experiment with flows, do sampling throughout the watershed, see how the system reacts, look for where the fish might be. But you're going to have to really do it all, roll up your sleeves. It's a comprehensive effort in the end. To make it successful, you're going to have to do it all. You need a plan. Yes. Sure. Yeah. To be honest with you, I couldn't answer your second part of that question very well. That's more of, and then the first one is a legal question. Yeah. Um, I think it varies depending on if you're on private land, public land, that sort of thing. I think there's a lot of cooperation going on in places, but um, the dam owners and operators know about 5937. It probably keeps them awake at night. Okay, seriously. And so I think there's a lot of room to work cooperatively. Nobody wants to, that's my personal opinion, litigate things, but certainly that has happened in Pewter Creek, on the Napa River, where a gentleman was trying to get some flows out of the dam there, some dams there. Um, the water district actually agreed to settle out of court to avoid that court situation. And they came to a really good solution on that. And so, I don't know what the percentages are, but certainly um, I do know it's a law and it's a requirement that hasn't been enforced. Yes. That's a good question. Maybe we should, spend some time talking about that. I'd be happy to talk about that with you because it could be, it can be really involved, I would think. But I think having that is really important because, you have to have something you can hand people to say, this is what we're envisioning. This is what we're looking for. It's an important piece. And then there's going to be a lot of science and a lot of study that's going to have to follow that, a lot of negotiation and that sort of thing. But I think if you can articulate clearly what it is you're striving to accomplish, that goes a long way. Yes. I guess the one thing I'd add is the conversation, in my personal opinion, shouldn't be starting with, will you please release water for the fish? It should be, let's sit down and figure out a way and how much and that sort of thing. That's where it should be starting. The baseline should be sort of at that point, you know, shouldn't have to beg. Yes. You know, there's going to be the latter, but with the caveat that, you know, there's going to have to be additional study. We don't know everything. You know, we haven't done all the studies that would have to be done. I think that the area of habitat could be increased. How far down, I couldn't say right now. Certainly could. And the other thing you have to remember about this, that we're, you know, it's not just the steelhead. We're looking for a healthy fish community, okay? We got sculpins and suckers and sticklebacks and birds and other creatures that would benefit from the flows. So, you know, the steelhead are sort of the focus because they're sort of a, you know, they're a threatened species and they're important, and people like to talk about trout and that sort of thing. But really, um, the community could benefit even if you don't get a huge steelhead run restored or a small one, you know, or you just end up with resident trout. You certainly could improve the condition of that community. So, no. Yeah. Yeah, thanks for your comments, and I agree with probably 90% of what you said. Okay, it's not an easy task. It's difficult. Okay, but there are analogs around the bay. You know, you can go over to Saratoga Creek, you can go over to San Mateo Creek. You can, you know, there's a lot of situations where you have these reservoirs and you have steelhead runs below them. So there are situations that you could use to help inform this situation. But it is there are multiple uses. I'm not saying that, but there is a public trust requirement, to have enough water in the stream for healthy fish communities. And, I think it can be, my best opinion is it can be balanced out with all these other competing uses. Yes. Um, well, certainly, you don't want to create sort of a focal point for predators to come and eat all your fish. But I think if you have the right flows, if you design multiple pools, multiple habitats, I think, over in Sausal Creek, the fish have been persisting there for a century now or more, that we've been monitoring them or had records of them. And so, and we've constructed those pools there. Raccoons do get in and eat them, and there are cats and things like that. It's certainly something you have to consider as far in terms of population persistence, but I think it can be overcome, be my sense. Yeah.